Hello everyone, I am Muhammad Isaq and I hope everybody is doing good. So let us continue with the chapter number 2, motion. Okay, chapter number 2, motion. So we'll just quickly revise the previous topics which we have studied. So the first terminology which we have seen is a rest. Okay, state of rest or commonly known as rest. So definition for rest is when an object, okay, with respect to the objects around it does not changes its position, then we say it as the object is at rest. Okay, whenever the object is not changing its position with respect to the surrounding objects, it is known as the object is known as, the object is said to be at rest. Okay, similarly whenever the object is changing its position with respect to these objects around it, then it is known as motion. Okay, then it is known as motion. So we have seen the motion, how the motion is related with motion, and how we have seen different conditions and different examples for this, and we have also discussed the definition of distance and displacement. Okay, definition of distance and displacement. So definition for distance is, it is the length of actual path, okay, length of actual path traveled by a body between its initial position and final position, between its initial position and final position. And what is displacement? The shortest distance between the initial point and final point is known as displacement. Okay, known as displacement. See, now we'll move on. See, we have distance and displacement. So distance is a scalar quantity and displacement is a vector quantity. Okay, so what is the difference between the scalar quantity and a vector quantity? In a scalar quantity we will have magnitude and we'll have magnitude but no direction. No direction. Okay, we have magnitude but no direction. But whereas in vector quantity we'll have magnitude as well as direction. Okay, we'll have magnitude as well as direction in the vector quantity. Okay, so instead of the, actually what is magnitude? Okay, this magnitude is nothing but the amount of content. Okay, you can say that the amount of content is known as magnitude. Generally this magnitude would be in the form of numbers. Okay, magnitude would be in the form of numbers. So in this place I can even consider speed. Okay, so distance has speed and time. Okay, speed and time but no direction. Similarly over here in displacement we'll have speed and time and also direction So this is about distance and displacement. Okay, so now we'll see activities. Okay, activity 1 and activity 2. So in activity 1 what I am considering is, so let us consider a ball. Okay, so I am throwing a ball with some intensity, with some velocity, okay, with some speed. So let us consider this is my ground and from here I am throwing a ball. Okay, I am throwing a ball in this direction. Okay, with some velocity. Okay, with some velocity I am throwing a ball. So what happens? The ball travels in this direction and it curves down and falls on the ground. Okay, the ball will fall over here. So the distance distance or length traveled by the ball, okay, the length traveled by the ball is nothing but distance. Okay, this length traveled by the ball is known as distance, which is represented by S. Okay, distance is represented by S. Distance is represented by S. Now what is displacement in this diagram? See, the shortest distance between the initial point and final point, okay, is the definition for displacement. So this is my initial point, I will mark it as I, and this is my final point where ball is falling. This is my final point. So the shortest distance between this is here to here. Is the shortest distance. This is the shortest distance. So the shortest distance is known as displacement. Okay, the shortest distance is known as displacement. So this is the activity 1, where when I where if I throw a ball, it curves down and falls on the ground. The distance covered or length covered by the ball is known as distance, which is denoted by S. Okay, and the shortest distance between the initial point and final point is known as displacement. Now this is the activity to identify the distance and displacement. Okay, to identify distance and displacement. Now our second activity is to create or to find out the displacement. So let us consider, this is my figure. Okay, so this is my initial point A, this is my point B, and this is my final point C. Okay, so let us consider this is a distance. Okay, this is a distance. Now how should I draw a displacement for this? Okay, the displacement would be a shortest distance. Okay, so from initial point to final point, if I draw a vertical line, if I draw an inclined line which passes through initial and final point, which is nothing but my displacement. Okay, this is my this is my displacement. Okay, this is my displacement. Now similarly, I'll just consider one more diagram. So let us consider like this, somewhere this path. Okay, so this is my initial point A and this is my final point B. Okay, this is completely one distance. This is the complete one distance. Let us assume a car is moving in this direction. Okay, the car is moving in this direction like this. Okay, this is the distance covered by a car. This is the distance covered by a car. So now we know this is the distance. And how to find the displacement? The shortest distance. Okay, so if I draw a line between A and B, which is my initial point and final point, okay, this is my displacement. Okay, this and this. Okay, this is my displacement, which is the shortest distance between A and B. Shortest distance between A and B. I hope you understood the differences between the distance and displacement. Okay.